Namaskar everyone. I wholeheartedly welcome you all to our YouTube channel Civil Engineering Simplified yet Detailed. With this video, we will start the first lecture of Geotechnical Engineering course. As discussed in previous video lecture, this is the syllabus of soil mechanics which we are going to follow. In this video, we will understand the significance of geology in civil engineering. We will look at the examples of few disasters that can occur due to ignorance of geological formation or discontinuity during construction work. We will also briefly overview the formation of the earth and its internal structure. Railway lines, expressways, dams, bridges, tunnels, multi-story building or any other civil engineering structure can be built on any part of the earth like hills, valley, deserts or water. Therefore, it becomes important for a civil engineer to know about the geological formation of that part of the earth where this construction needs to be constructed. Geology mainly studies the earth and its internal structure, rocks and their formation. In geology, the changes that have taken place over the vastness of geological time and the changes that can occur in future is studied. In this course, we will study only that part of geology which a civil engineer is required to know. Development should be such that it saves us from disaster and not such that it itself becomes a disaster. Hundreds of people have been killed and thousands badly affected due to massive landslide in the southern Indian state of Kerala. On 4th October 2023, heavy rains caused a glacial lake outburst flood in northern part of Sikkim. The flood reached the Tista Dam at Chungthang at midnight, before its gate could be opened, destroying the dam in minutes. Water level downstream in the river Tista rose up by up to 20 feet, causing widespread damage. Many buildings and bridges have collapsed. Thousands of people were severely affected. You all must be familiar with the place named Josimath. It is a beautiful town situated in the foothills of the Himalayas, located in the state of Uttarakhand. This place came into the news when subsidence incidents occurred in many places of Josimath region. Cracks were developed in many houses and road started sinking in several places. Central Building Research Institute stated in its report that Josimath town has 99% non-engineered masonry, RCC and other construction. These structures are not in compliance with the National Building Code of India. In its report, the CBRI says that Josimath town is situated on Vakrita group of rocks overlain by morainic deposits, which are composed of irregular boulders and clay of varying thickness. Such deposits are less cohesive and susceptible to slow subsidence and landslide subsidence. According to ISRO's finding, seepage of local drainage water into the soil causes slope instability in the area. The 12-kilometer long head race tunnel of Tapovan Vishnugad hydroelectric power project was also being blamed for the disaster. The reason for discussing such incident is that no construction work should be carried out without knowing the geological strata of the proposed site. This is why a civil engineer must have basic knowledge of geology. We live on Earth, a planet in solar system with 7 other planets. Earth is the third nearest planet to the Sun. Earth is estimated to be around 4.5 billion years old. Nebular hypothesis by Immanuel Kant, Big Bang theory by Edwin Hubble and many other theories were given related to the origin of Earth. The most popular argument regarding the origin of the universe is the Big Bang theory. It is also called the expanding universe hypothesis. Edwin Hubble in 1920 provided evidence that the universe is expanding. At its beginning, Earth was unrecognizable from its modern form. At first, it was extremely hot to the point that the planet likely consisted almost entirely of molten magma. Over the course of a few hundred million years, the planet began to cool and oceans of liquid water formed. The shape of the earth is an oblate spheroid. Oblate spheroid means it is spherical in shape but not perfectly round. It is slightly bulged at the equator and is flattened at the poles. In 1912, German scientist Alfred Wegener proposed a theory called continental drift. Hundreds of millions of years ago, all the land of Earth was joined together in one large mass or supercontinent, which he called Pangaea. Then about 200 million years ago, the land began to drift apart. It broke into two pieces, and scientists have called the continent in the north as Laurasia and the continent in the south as Gondwana land. Kindly note, our country and continent Asia is the part of Gondwana land. The two large continents continue to break apart into the smaller continent that exists today. Scientists call this movement as continental drift. Geological activities such as earthquakes, movement of tectonic plates affect the stability of civil engineering structure. That is why a civil engineer must have knowledge about the interior of the earth. The earth radius is about 6,378 km. No one can reach the center of the earth and make observation or collect sample of the material. The interior of the earth can be understood only by indirect evidence, as no one can reach the interior of the earth. The interior of the earth can be classified into three major categories as crust, mantle and core. Crust is the outermost solid part of the earth. It is brittle in nature. The thickness of the crust varies under the oceanic and continental areas. Oceanic crust is thinner as compared to the continental crust. Oceanic crust extending 5 to 10 km beneath the ocean floor and is mostly composed of different type of basalts. Geologists often refer to the rock of the oceanic crust as sima. Sima stands for silicate and magnesium, the most abundant mineral in oceanic crust. Continental crust is mostly composed of different type of granites. Geologists often refer to the rock of the continental crust as sial. Sial stands for silicate and aluminium, the most abundant mineral in continental crust. Compared to the layers below, crust has high rigidity and anisotropy. As far as civil engineering is concerned, the main concerning part of the earth is the crust, as the depth of foundation lies in the crust only. Talking about some interesting facts, at 8,849 meters, the Mount Everest is considered the tallest point on earth. It is located in Nepal. In the 19th century, the mountain was named after George Everest, a former Surveyor General of India. The Mariana Trench, located in the West Pacific Ocean, is the deepest oceanic trench. The maximum known depth is 11,000 meters, that is 11 kilometers about. Ponding gold mine is the world's deepest mine from the ground level. It is estimated to be 4 kilometers deep. The portion of the interior beyond the crust up to a depth of 2900 km is called mantle. Moho boundary or Moho discontinuity is the boundary between the crust and the mantle of earth. The upper portion of the mantle is called asthenosphere. The word astheno means weak. It is considered to be extending up to 400 km. It is the main source of magma that finds its way to the surface during volcanic eruptions. The rock that made up Earth's mantle are mostly silicates. Common silicates found in the mantle include olivine, garnet and pyroxene. Other mantle elements include iron, aluminum, calcium, sodium and potassium. The temperature of the mantle varies greatly from 1000 degrees Celsius near its boundary with the crust to 3700 degrees Celsius near its boundary with the core. In the mantle, heat and pressure generally increases with depth. From about 410 km to 660 km beneath Earth's surface, rocks undergo radial transformation. This is the mantle's transition zone. The lower mantle extends from about 660 km to about 2700 km beneath Earth's surface. The lower mantle is hotter and denser than the upper mantle and transition zone. The crust and the uppermost part of the mantle are called lithosphere. Earth's core is very hot, very dense, center of our planet. The core is found about 2900 kilometers below Earth's surface and has a radius of 3485 kilometers. Unlike the mineral-rich crust and mantle, the core is made almost entirely of metal, specifically iron and nickel. Another key element in Earth's core is sulfur. In fact, 90% of sulfur on Earth is found in the core. The core is made of two layers, the outer core and the inner core. The outer core about 2200 kilometers thick and is mostly composed of liquid iron and nickel. The outer core is very hot, between 4500 degrees Celsius and 5500 degrees Celsius. The inner core is a hot, dense ball of mostly iron. It has a radius of about 1220 kilometers. Temperature in the inner core is about 5200 degrees Celsius. With this, I would like to conclude this video. Now we have reached the end of this lecture. Let's recap what we have discussed in today's lecture. First of all, we understood the significance of geology in civil engineering. Then saw many examples of disasters and their consequences that occurred due to ignorance of geological formation or discontinuity during civil engineering construction. We also discussed the story of how the earth was formed and how it went through various transitions state to become what it is today. The stability of a structure depends on the soil on which it is being constructed. Along with the earth's uppermost layer, we have also briefly looked at the earth's internal structure, that is crust, mantle and core. In the next video, we will discuss another topic of this course. Stay tuned with us, subscribe this YouTube channel, share this video link with all your civil engineering friends. All the best. Jai Hind.